Let us look at the solutions for the questions in quiz 2. So there are 4 questions in quiz 2. This is related to arrays. So based on the topic, I have given the question. So let us see the solutions. So the first question. So first question says that if there is an array of type integers and the dimensions, 2 dimensions array. So the dimensions are 1 to 10 and 1 to 15. And the base address of an array is 100 and the size of integer is 1 byte. Word size is 1 byte. It is given in the question. So I have written it like this. Then we have to find out the address of any location I and j. What will be the formula? Because the formula is known formula and in that we already know L0, that is location 0, and W. So we can use that and still it will be a formula. We will not get a single value because we don't know I and j. So what is the formula? See, formula is L0 plus I minus 1 into n plus j minus 1. Why I minus 1 and j minus 1? Because the indices are starting from 1 onwards. Like in C, C++ or Java, the indices starts from 0 onwards, but here it is starting from 1. So in old languages, it was allowed to start index from 1 also. So when it is 1, so we have to write I minus 1 and also j minus 1. If it is 0, just we can take I. Now what is n? So the dimensions are n cross n. So this is n, right? This is n. So now let us put the values. L0 we know 100, right? Then I minus 1, okay, I minus 1. And this is n, that is 15. This is 1 to 15, so it is 15 into 15. Then plus j minus 1. So j minus 1 will be as it is. So I'll keep it open. Now how much this is? This is 100 plus 15i minus 15 plus j minus 1. So this is 15i plus j, and this one is 100 minus 15 and minus 1. So minus 16, if it is done, then it is 84. So this is the correct answer. 15i plus j plus 84 is the correct answer. So this is the first question. Now second question, this one. This is little difficult for the student, so I'll explain in detail. Watch this one. There is a 2-dimensional array of dimensions 4 and 3, that is 4 rows and 3 columns. So here I have drawn it here, 4 rows, 0, 1, 2, 3, 4 rows, and columns are 0, 1, 2. And it's already initialized with values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, all these numbers are there. And the base address is given, that is 2000. And this is integer type and the size of an integer is 4. So this is given in the question. So already I have drawn in the diagram here and I have filled the values. Now let us go towards the solution. Base address is 2000 and integer is taking 4 bytes. So first address is 2000, so I wrote 0 for that. And next is 2004, 2008, 2012. Plus 4, right? Plus 4 is 16, plus 4 is 20. So I have written the addresses of all these locations. So you know very well that in the section we have studied that 2-dimensional array means actually the memory will be allocated in single dimension form. So the addresses start from 2000. So this is 2004 because integer is 4 and 8. The next is, this is 2012. So likewise, this is 2036, 40 and 44. So these are the addresses. Now the next important thing we should know for getting the solution is how to access the elements using pointer arithmetic. Suppose I want to get the value 8. How to get the value 8? See, 8 is row number 2 and column number 1. So how to get that one? X plus row number 2, x plus 2. Then here star, okay, 1 star. Then column number is 1. Plus 1, then this whole thing should be inside star. This is how we can access any location or any data inside any location at any given location. So 2, 1 I am accessing. If you want to access 1, 2, then write this as 1 and this as 2. So important thing in this one is we need 2 stars for accessing data. If I remove 1 star, then what I get? I get address of the data. I don't get the data, I get the address of. So what is the address of 8? It is 28. So this is 2028. So it's starting is 2000. So I have not written 2028, just 28 I wrote. It's 2028. Next, in this, if I remove this plus 1, if I remove this plus 1, so it means it will not go to this row 1. Then whose address I get? I get the beginning address of this second row. X plus 2 means this is second row, x plus 2. So first plus is for row and second plus was for column, right? So if I say x plus 2, I'll get the base at beginning address of the second row, that is 2024. This is what I get. And one more thing, if you remove this star also, then also it means the beginning address of the second row, that is 2024. It means same whether you write star or don't write star, because you will not be getting the value. So definitely it's address. For value you should have 2 stars. Remember this. Now we are able to get the solution. So what is asked here? First thing is, what is x plus 3? Percentile u is used there for printing the address. So what is x plus 3? X plus 3 means third row, beginning address of third row. What is this? 36. So 2036. So this is 2036. Right? Next, if I write star, I'll not get the data. It is x plus 3, third row only, same address only I'll get. So what is the address of the third row, beginning address? That is 2036. 2036 only. Same thing. Now next, star x plus 2. So beginning address of the second row means this one, 2024. Plus 3 means 1, 2, 3. It's again same address. This is also 2036. Again, this is also 2036. X plus 2 star means this address 2024, right? Then plus 3, 1, 2, 3. So 2036. That's it. So the answer for this 2036, 2036 and 2036. 3 times it is given. So this is the answer for this question. Now the next question is third question. Here the question is, there are 2 matrices A and B. Matrices can be represented either using row major mapping or column major mapping, right? By a compiler, they can be represented in any way. But C language and C++ compiler follows row major mapping, right? We have already discussed this one. Now coming to the question, it says that if A and B are being multiplied, we have to perform such an operation. Then if your compiler, you are writing a compiler. So in your compiler, for such a situation, what do you prefer? If A and B are multiplied. So matrix A multiplied by B means if you have 2 matrices, right? So if you know the matrix multiplication, rows are multiplied with columns, right? Elements in a column. Row with column, we get the product of 2 matrices. Row with columns, right? We multiply and get each element. So you know the matrix multiplication procedure. So you should know the procedure. Now the question is, if I am multiplying these 2, then which mapping is better? So the options are given, that first one is row major, second one is column. Because rows are multiplied with column, so the first idea that you may be getting is, first one A should be row major and B should be column major. That is the wrong answer. The right answer is, any representation can be used. Reason, which representation is better? So if you see the row major formula, I have just written the formula here, column major formula, how many operations are there? 2 additions, 1 multiplication, 2 additions, 1 multiplication. Both are equally efficient. So efficiency is based on the operation. So how many operations we have to perform to calculate this formula, and for this one, they are same. So both are equally efficient, right? So the answer is it's independent, or both are equally efficient. You can use any one. Right? Not specific, first one is row major or second one is column. Both can be row major, both can be column major, any combination. 4 combinations are possible, any one can be taken. So it's independent of any representation, right? Now you may be thinking that if n values is small, then the number of multiplications will be more. So then I will say m value may be small also. So it's not based on value, it's based on just number of operations. So both are equally efficient. So you can use any method. Independent of representation is the right answer. Now the next question is fourth question. So this is little lengthy. I'll remove this and I will do the work for this one. The question is, there is a 3-dimensional array. Name of this array is X, and There are 3 dimensions, L, M, N. We don't know what are the dimensions. We don't know the data type also. And if the size of an integer is 2 bytes and the size of float is 4 bytes, this is given in the question. And the question says that for evaluating the address for a 3-dimensional array, compiler is performing following steps. And these are the steps given. Then from these steps, can you find out what are the dimensions and what is the data type? This is the question. So when the compiler is performing the operations, it is using row major representation. Okay, row major representation is followed. And these are the intermediate steps. So now we have to find out what are the values of these dimensions and the data type. So for the solution, I have taken it here. Data type we don't know. Dimensions are L, M, N, right? 3 dimensions, 1, 2, 3. Then what is the row major formula for 3-dimensional array? Address of x of I, j, k is L0 plus I into mn plus j into n plus k. And this entire thing multiplied by w. This is the formula. And in this, one thing to observe is, we have mn, right? Mn, ijk is there and w is there. So we don't have L. So yes, we cannot find out L. We cannot find it out. But we can find out mn and w. These are the values that are variables that are used here, right? Then, if I expand this formula, it will be like this. Now, if you reach till here, then you know the answer from here. Let us see, this is the formula. This complete thing multiplied by w, so I multiplied by every term with w. So I have multiplied every term with w. Now see this, compiler will not execute the entire formula at once. It has to do step by step, like multiplication is done, then next is done, then next is done, then addition is done. So each operation, it takes one machine instruction. So step by step it is doing. So that's what it is shown here. Steps are there. This entire formula cannot be done. If I give you pen and paper and I give you values and ask you to solve it, you cannot do it at once. For example, if I say 3 into 42 plus 9 into 73, just do it. So in a single glance, can you give the answer? No, first you will multiply this, then add it. So the same way, compiler is also performing them step by step. Now solution. In the formula, what is multiplied with k? K into w, k into w. So here in the steps, k into 4 is there. So k into 4 is there means, what is the value of w? 4. So w is 4. That's it. So it's so simple. We know the value of w now. Then if you see this, I started with the smaller one, not this one. This is having 4 things multiplied. So I took the simple term. Then j n w. So j is multiplied by n into w. So what is the value with the j? 32. So that is 32 means it is actually n into w. So n into w is 32. Then what is n? N is 32 by 4, that is 8. So now we know n is 8. Then the last thing, I is multiplied by m into n into w. So here it is 1024. So this is m into n into w. So m into n into w, this is 1024. N into w already we know that was 32. So this is m is equals to 1024 by 32. So if you divide this, this is 32. That is 32 into 32 is 1024. So we know the value of m also, that is 32. So now we know the values. W is 4. 4 means this is data type. W is data type, float. So this is float. Data type is float, right? And x, as I said, the first dimension we cannot know, right? Then what is m? M is 32. M is 32. And n is 8. That's it. So whatever it may be. So if you check the options, among the options, only one option is having float here and 32 and 8 here. So whatever it is, 12 is written here, 12 or anything, whatever the value may be, it will be true because this one and this one and this one are same. So there is only one option that is true. So that's all. These are the solutions for questions in quiz 2.